All right, so this bonus loading objective, we're going to talk about graphing rational functions. So we've looked at graphs in some of our other videos, but you haven't had to create the graphs yourself, so now we're going to learn how to do that. All right, so graphing any rational function is something that we covered in pre-calc. All right, here we're just going to look at kind of a simpler case of graphing a linear term divided by a linear term. That means there's not going to be any x squareds or anything like that. All right, so in order to graph a rational function, we need four main things. All right, the x-intercepts, and we found x-intercepts before. That just means you set your equation equal to 0. The y-intercepts, we've done that before. You plug in x equals 0. Vertical asymptotes, we've done that before. That's when the denominator is equal to 0. And horizontal asymptotes, that's when you compare the degrees. That was the 6.25 linear objective. All right, so those are the four different things, both types of intercepts and both types of asymptotes. All right, the only thing that'll change really when you're doing it in pre-calc is the x-intercepts and vertical asymptotes. There'll be some simplifying and stuff you have to do, but y-intercepts and horizontal asymptotes are pretty much the same no matter what. All right, so let's graph this function, x minus 3 over 2 plus x. So first thing, x-intercept, we're going to take our equation and set it equal to 0. All right, similar to in 6.16, when we're solving an equation with a rational, the first thing we do is multiply everything by the denominator, so it goes away. And on the right-hand side, you're multiplying by 0, so it's just 0, and I add to get 3. So my x-intercept is 3, so I can go ahead and put that on my graph. Next is my y-intercept. That's when I plug in 0, so I'm going to get 0 minus 3 over 2 plus 0, negative 3 over 2. So negative 3 over 2, which is negative 1/2, which is there, is my y-intercept. All right, next is my vertical asymptote. That's when I take the bottom of my fraction and set it equal to 0. So subtract 2 to the other side, that's at negative 2. So negative 2, this is, the vertical asymptotes and horizontal asymptotes are interesting because they're not actually a part of the graph of your function, but they're really important to have. So I'm lucky I can put them in as a different color, but one thing you always do with your asymptotes is you put them in as dotted lines. So dotted lines represents the fact that they're not actually part of your graph, but they're just important information. And we'll do the same thing with our horizontal asymptote. Horizontal asymptotes, we compare the highest powers of x. So on the top it's x, on the bottom it's x, and that's 1. So horizontal asymptote is 1. And so now I have all of my pieces, and now I can graph my function. So I know as I go along, I have to kind of connect the dots. As I go all the way to the right, my horizontal asymptote takes over. So as I go farther to the right, it should level off there. As I get close to my vertical asymptotes, I should either go up or go down. I can't cross that line. And if you imagine for a second, if I tried to go up, I'd have to cross the x-axis, but I know that doesn't happen because I only have one x-intercept, so I have to go down. And then on the other side of here, this is where you can use some reasoning, or you can use some math things that we learned. So if I use some math things I learned, I don't know what's happening to the left over here. That's what I could do is just plug in a value like negative 4. I could plug in negative 4. Negative 4 minus 3 over 2 plus negative 4 is negative 7 over negative 2. And that is 7 over 2 is 3.5. All right, so I know if I plug in negative 4, I get 3.5. Negative 4, there. All right, so that's one thing you could do. And then you use the same logic to the left. I have to level off at my horizontal asymptote. Going towards my vertical asymptote, I have to go upward, because if I try to go downward, I'd have to cross the x-axis, and I know that doesn't happen. All right, so this is my final graph. All right, rationals are kind of a weird one because there's a lot to find, and also even after you find everything, you might still have to plug in some values to get your final graph. All right, make sure you get all the pieces of your graph and put them together. All right, so let's do another example. Again, they're all going to be the same thing in terms of the steps. X-intercept, set your equation equal to 0. I multiply by the denominator, so you get rid of the fraction. And again, you're multiplying by 0, so the right 0. Subtract 1, divide by 2. All right, so my x-intercept is -1/2. That's there. My y-intercept, then I plug in 0. -1/4, so that's going to be there. My vertical asymptote is when the denominator is equal to 0, which happens at 4. So I put that on again. Asymptotes are going to go on as dotted lines. And my horizontal asymptote, the highest power on the top is 2x, highest power on the bottom is x. That simplifies to 2. So my horizontal asymptote is 2. And I think about, first of all, I just connect these two, because that makes sense. As I go all the way to the left, my horizontal asymptote takes over. So as I go to the left, I should get close to that horizontal asymptote. As I get close to my asymptote, I know I go down, I go up. And again, that's kind of half the graph, because I need to figure out what's happening on the right-hand side of the asymptote as well. So you could plug in a test point like we did for the last example, or you can just kind of use some logic. If I put a point down here, to get up to my horizontal asymptote, I'd have to cross the x-axis, which I know doesn't happen, and I only cross the x-axis there, which means I have to be up here. All right, again, it's up to you how you want to figure out these things. You can always just plug in a bunch of points. I could plug in 5 and get a value and figure it out. All right, but this is a good sketch of this rational. All right, another thing to keep in mind is because all the graphs we're looking, all the functions we're looking at are kind of similar, all their graphs will look pretty similar as well. All right, so go ahead and try this one on your own, x minus 1 over x plus 3. As after you find all the important information, you have your x-intercept at 1, y-intercept at -1/3, vertical asymptote at -3, horizontal at 1. And when you combine them, again, it's going to look similar to all the other graphs we've done because they're all similar with just small changes. All right, so that's my final answer for the graph of this rational. All right, so for this learning objective, you're going to do a skill check. All right, this takes a lot of work. You have to find 2 intercepts and 2 asymptotes and put it all together to get a graph. So you're just going to have to do one problem, right, just one rational that you're going to have to graph.